Is R. Subramanian. Thank you everybody for taking time and joining the session. I just want someone to confirm through the chat window, is my audio is okay? Are you able to see the window or my desktop presentation I shared? Are you able to see that? Or is my audio is okay? Can somebody type it on the chat window, please? Okay, thank you. Uh, Thank you. I got a confirmation that you are able to see my presentation shared, and also my audio voice is my voice is audible over there. Okay. Thank you very much. Let us start now. So this is we are going to do 3 to 4 sessions on the network management. As you all know, we are having a ITOC, IT Operations Center based out of Pondicherry and also at Noida. So this facility is going to provide the management services for the all our enterprise customers, and we will be managing multiple enterprise customers from the common facility. Just 1 minute. Still, I hear the hissing voice, so maybe you'll have to see somebody needs to be muted. If somebody is, I hear the hissing voice. Sorry. Um, Sorry about that. And everybody are there, kindly mute your phone so that we don't, the audio quality is better for everybody. Okay. So we are going to do 3 to 4 sessions to understand the concept of MIS, concept of the network management. So the first session, this is the first session where we are going to talk about the basics of network management. Hey, 1 minute. So there is one guy is, you do that, right? Okay. I'm requesting everybody to be in mute because even one person not done that, you will every whole audience will hear the hissing sound or problem. And I currently I see somebody is not muted, and everybody voice quality is disturbed. Okay. Okay, fine, perfect. Thank you. So the first session is the general session. What we are doing today. In the general session, we will be talking about the concepts of network management. That is why there is an NMS required, and how the generally NMS architecture is done. The second session is going to be an advanced session. It will take you to the configuration level, the different elements which needs to be managed. The third session which we are planning is more of understanding of NMS tool itself. It could be the CA ones, and the subsequent sessions we can do Mastro. So these are the 4 sessions we are planning. Today, the first session is a concept of network management. Why we are doing this session is, today we are talking about managing nearly about 20 to 25 customers, enterprise customers, from the common ITOC facility at Pondicherry and Noida. Going forward, we are looking for more and more customers who are managed from our ITOC services. So to manage the enterprise customers assets, it could be network, it could be servers, it could be application, security, or anything which is IT or non-IT type of infrastructure. We should have access here, and we should be able to manage that, whether their status of whether it is working or not, or whether performance is okay or not. Various parameters we will be managing it from here, and in the event of there is a violation or there is a failure noticed, we take corrective actions by informing the customer, or if there is a SOP, standard operating plan, signed up with the customer, as per that we will do certain corrective action as well. So this is the high level plan of why we are doing this session. Irrespective of whether we manage the customer based out of ITOC or not, customer also may have their local NMS. Many customers, many enterprise customers having large networks, they will have NMS to manage the entire IT infrastructure. So that means, for us, we, of course, many customers, we do the end user computing support, but many other customers, we are also getting into the data center management, and we are also getting into wide area network management, etc., where The monitoring is more of a proactive rather than reactive. Today, what happens is when there is someone's desktop is not working, the customer calls you. That is, my PC has some problem. Then you go and attend to that, you fix that. So this is more of a reactive type of support. Reactive in the sense customer calls you, after that you go and fix it. But the concept of network management, it is little different. The network management monitor all of them are working or not, and in the event of failure, immediately it is notified to the NOC operator, that is a network operation center engineer. Immediately you come to know there is something happening. It could be a threshold violations, or it could be a link failure, node failure, higher CPU utilization. Immediately you get an alert, then he will go and look at what's happening there, and he will fix those issues before it becomes serious. And based on SLAs, it's also informed to the customers, a trouble ticket is created to close those whatever issues observed. So this is more of a proactive type of things. Here in this case, there is no concept of customer calling us saying that this equipment is failed. It is we going to tell the customer your equipment had a problem, we fixed it already. So that is how this entire model going to work. And so part of that, the concept of network management is extremely critical for engineers of you, because on the field you will be the people who are integrating all the network elements. Network elements could be the routers, switches, security elements like firewalls, or maybe servers, applications, storage. Everything gets connected to the the network management. Okay. The second point is, today if you take the S4N side, S4N, S4N stands for server, storage, security, services, and also the network. Almost every elements on the customer IT infrastructure side, they have an IP interface. They can be managed, they can be verified or accessed for their availability and performance using a simple ICMP ping that particular IP address. You will know whether on periodic basis the software can check whether the element is responding it or not. That is one way of monitoring. Second way of advanced level of monitoring is using SNMP type of protocols. SNMP is supported across all the IT infrastructure, right from all the servers of all different operating system, Windows, Linux, VMware, everything, and storage, security devices, every device of the customer IT infrastructure, they support SNMP. So using SNMP, you can pull more and more statistics of the utilization of different resources, and then provide the customer proactive services. So this is about the higher level the introduction about why we need to understand the network management concepts. How is it going to reflect in our day-to-day work? How is it going to help our enterprise customers to provide proactive services as compared to reactive services? And I'm sure when we go through these slides, you will have a lot of questions coming up. So whenever you have a questions coming up, what you do is you put that question in the chat window. So what we do is, there are one topic to another topic. When we change, we go through those questions, and if that questions were not answered already during the sessions, we will answer that. So with that introduction, let me go to the next slide. Okay. Okay, this is also a instructor-led training, and hence this can be. So this is the only way to change the slide. Okay, no problem, no issues. I will change it like this. Okay. So the agenda of the today's session, next 2 hours, what we are going to do is one, we study what is the concept of FCAPS, then the protocols and technologies used in the NMS concept, preparing the network for the management, and IT Operations Center, how does it look? HCL IT Operations Center, which is the new IT Operations Center which we built in Pondicherry. How does it look? And then some introduction about CA UAM, CAUM is selected as a tool for our managing the customer facilities. And we also have our own homegrown tool, Maestro. Now Maestro has become Maestro Plus. So some what are the different modules, etc. CAUAM and Maestro, we will talk at a very, very higher level. We will have a follow-up sessions which will get you into deeper level. And the rest of the things also we will do. Today's discussion is at an introductory level, make you understand what it is, but we will also do a deep dive sessions going forward. So let us begin with what is FCAPS, right? FCAPS stands for okay. Okay. Like, the OSI 7-layer model, you must be familiar with physical data, network, transport, session. That a 7-layer OSI model you are familiar with when it comes to the IP or TCP IP type of, how to represent that as a 7-layer OSI model. The same OSI model, there is also for NMS, there is a model layers defined. That is the FCAPS, right? Fault FCAPS, if you look at the first letters of fault, configuration, accounting, performance, security, they combine together, they form FCAPS. And many times it is also added with the word management, fault management, configuration becomes configuration management, accounting management, etc. So let us look at what is fault management and individually all the parameters. We will go through them one by one, right? Right. So the fault management. So let us say a customer has a network, right? It may be let's say, for example, it may be a WAN network. So let's say a bank has built a WAN network to connecting all their branch offices, ATMs, etc. It may be a mesh network or maybe a partial mesh network. Every branch may have more than one link to reach out to the main data center. And so that, there is no single point of failure is there, right? And let us say there is one link has failed. Then if there is one link has failed, then what happens? How does but as far as the end customer applications are concerned, it will continue to work. The branch office is concerned, it will continue to work. Why? Because there is a redundancy built with the network. So every branch office has, if it is having two links, two alternate links, one link goes through some particular route and another link goes through a different route, or maybe dual uplink to some regional offices, and then all regional offices interconnected with the main data center, right? So some kind of hierarchy customers will build. So when there is one link failure has happened, and the branch, they don't even notice there is a one link failure. There is one link is failed, and they continue to work because there is a redundancy, is already operational. But what happens if the second link fails later some time? So that means, immediately the branch gets disconnected because the backup link also failed. So it is important that when there is a one link has failed, the NOC operator or the customer gets a notification that there is a link has failed, and hence, it has to be fixed immediately. If it is not fixed immediately, what will happen? Later sometime that banking from that particular branch office they will not be able to do. Let us consider a second example is, let's say on the picture what you see is the data center infrastructure. Bottom two switches are core switches, and the top one switch is the access switch, LAN switch, right? And you see they are connected in a dual uplink. One uplink goes to the one core switch, other uplink goes to the another core switch. And they are initially pre-configured to work as a, let's say, failover type of things. So failover means one link fails, other links take over the operations. So that's how it is configured, let us say. And during the operation, let us say that one link has failed, and customer will not notice that there is a failure. He will not even know about it because everything works normal. from the user point of view, from the application point of view, because there is a redundancy. But it is also important the customer fix this link before the backup link also fails. So you need some system which will check and notify there is one link has failed, right? So that means there can be a lot of fault. Similarly, it can occur in the network. So what we discussed is a failure of a link, but it could be a failure of a partial hardware, or maybe soft issues, something like CPU utilization is 90% or 95%, or sometimes it touches 100%. Memory utilization is exceeding the threshold, or or maybe a temperature of the equipment is going up, rising up. It could be any type of fault which is happening, needs to be notified so that the customer takes appropriate actions. Customer takes appropriate action before it becomes serious, right? So that is what is all about fault management. So the fault management, you have your system which checks periodically, pulls different devices health, whether it is okay or not. So let's say just for example purpose, every 5 minutes, okay, NMS checks every element which is it has to manage. It will ping and check whether there is any fault is there, right? If something is not responding, it knows that some link, some IP is failed, or something is not responding. That is from the NMS to the element. It is checking, right? The other ways to do is when there is a link failure, the network device notify to the NMS. It sends an alert to the central server saying that something has happened here, right? Then NMS gets an alert. Earlier it was NMS originated. Now it is a network element originated. It sends an alert to the central NMS, and then you get a fault message in the NMS knock or the screen, the console. You get a alert. Then what happens is the person can take actions to fix those alert, and to find out, maybe you can go deep dive into what exactly issues, or the knock operator can raise a trouble ticket so that L2 engineer or L3 engineer step in and then make corrective actions. Anyone newly joining, please mute it, because whatever you talk disturbs the whole audience. Who is that laptop issue? Yeah. Please mute. By default, you mute everybody. Whoever newly joins, please mute, right? It disturbs everyone, right? Please understand that. Okay, sorry. Let me come back here. So you understand what exactly the fault management role is all about, right? I think we tell also people don't listen actually. Still a lot of people are not muted. Okay, so the fault management, when it comes to, so it's a process of, I'm just going through now the points which are written in the slide, right? So the process of locating, diagnosing, correcting the network problems. So that's all about the fault management. It helps to increase the network reliability and effectiveness. It is more than just firefighting, right? Firefighting means primary failed, nobody noticed, and the secondary link also, backup link also failed. Then it starts, you are doing the firefighting, right? So that is firefighting. But here you fix it before it becomes serious. So that is why it is better than a firefighting, right? And it increases the productivity for all the network users. So now when it comes to how the successful fault management deployment is identify the problem by gathering network information about the state of the network, polling and trap generations. So there are two words which are we see here. One is polling, other one is trap generation. The polling, what it means is the NMS regularly checks with all the elements whether what is the status, what is the utilization. So that is polling. So your NMS goes and checks, various parameters using a protocol called SNMP. We will talk about what is SNMP subsequently. So it checks the status through SNMP regular basis, every 5 minutes or 10 minutes as per the policy, and then it analyzes which is it is within the threshold or not. So that is a NMS initiated looking for fault, or maybe it is just doing a ping and checks whether device responds or not. The second is a trap generation. Trap generation is more from the network element initiated. When there is a fault, the network element or the server or the, whichever the element we are managing, that sends a notification to the NMS. That's called a trap. Sometimes you call it as SNMP trap as well, right? So that is about the trap related things. How does it work, right? So the two ways the fault management can be deployed. In fact, it is not two ways, both are combined together, it is deployed. Then the when once the fault is occurred, then a network operator tries to fix the problem, or he raises a trouble ticket. So this is all the fundamentals of the the fault management. And if you have a question, please do put it on the chat. We will answer them once we finish the entire FCAPS. Now let's talk about the configuration management, right? Configuration management, in the sense, why, see, if you have a large number of elements which needs to be managed, let's say there are lots of routers, switches, Wi-Fi equipments, or a lot of virtual machines or security devices. So if the network has thousands of such things, just for your example, a telecom company, Reliance Jio, you may be aware that they are launching the 4G service soon, and they have deployed nearly about 1,20,000 routers, right? To do this 4G service across India. Fundamentally, they have 1,10,000 E-node Bs, which is basically the towers, and all from where it covers certain area for 4G service. And then every tower will have a router, right? And all these routers are backhauled or interlinked, and then brought to the central place, and from where all the services are activated. Some of the locations, the entire tower erections, router configurations, all done by HCL team, and now it's moving into the deployment. So the 1,20,000 routers, right? How do we configure and how do we manage it? Let's say that there is a configuration change required. There are some issues have come, or a new feature they need to add. They will have to go and add it in all the 1,20,000 routers across their network. How do they do it? Can they really do it with manually? Maybe putting maybe 1,000 engineers, doing this configuration. Probably it will take about 15 days to complete it. Whereas the same thing from the NMS, if they have to do all the 1,20,000 routers, whatever configurations are required, the changes required to be done, they can finish it in 1 or 2 hours time, right? See that from 10 to 15 days, still you can't be sure that it is error free, because ultimately it is done manually. All the human errors are possible, right? So now you are doing the entire thing from the system, from the NMS. So from the same example of Reliance, they have a configuration management. So the NMS concurrently makes 5,000 telnet sessions, remote login sessions to different routers, and make the changes and comes out and then pushes to the next 5,000. Within 2 hours, 3 hours, they will be able to configure the whole network across pan India. That is one example on the higher side. If you have to see the other things, like a bank, State Bank of India, if you take it, they have got nearly 22,000 branch offices across India, probably 40 to 50,000 ATMs. Everything has a network device, a server, or maybe something IP devices which needs to be monitored. So in this case, how does someone understands the what configuration is to go on which devices, right? There are certain things are common configurations, certain things are location specific configurations. So how does somebody understands that? So sometimes the configuration may be, you'll have to put a small locations. It could be maybe let's say that 40 lines to be typed out to make that site reachable to the main data center. That's a 40 lines put together. It is looking at configuration. Some other location it could be 60, some other locations could be 200 lines or something like that. And how does one remembers that? And if you ask engineers to do that, and each one will do in a different manner, because there are multiple solutions to every problem, right? So people will, there is no uniformity you can bring in by doing it manually with a different set of engineers at different locations. So managing such network is really a nightmare, right? So what they do is they use the NMS configuration management to configure all those elements. The way they do is they create templates. So any configuration has to be pushed through the template. So that means it doesn't matter how many branch routers, everything is there. In the template, it asks all the inputs, right? You feed in the IP address, host name, password, whatever the QoS policies to be done, etc. As a template, you just fill in all those data, and after that, configuration management pushes to the respective network elements to be done. So this is quite simple, right? And it is uniform, right? So this is only from the basic configuration, but there is also other things to be done for managing the configuration. For example, you may need to do a regular backup of the configurations. Why regular backup of the configuration required? Sometimes the production network, a unit may be failed, right? And you can get one equipment failed, and you can get another router. Yeah. So let's say that one equipment has failed, and then what you do is you can change the equipment, right? Let's say I have a LAN switch in our let's say one of the branch office, and the LAN switch has failed, and you can replace that LAN switch with another switch. But who knows about the old configuration? What was the original configuration running? And that needs to be restored. If you do not restore the old configuration, what will happen is equipment is replaced, failed unit has come back to production, but failed unit has been replaced, but it cannot come to production. The reason is the original configuration is not known, right? Nobody knows what was originally configured, and they struggle and they try to find out what was the configuration originally there. But that is also can be avoided if someone takes a regular backup of the working configurations, so that when the equipment fails, you can just simply copy the configuration from the central configuration management, and the whole network can be brought to the production in production in a very short span. So what you can do is one is managing the new configurations using templates, right, and backing up the configuration, and then restoring the configurations. It could be only the equipment related configuration, or it could be some software versions also. Sometimes you have to have a different software version. You need to push for software versions. So those type of things you can always do that using the configuration management, right? So I hope you got some idea about what is the configuration management is doing it, right? So let me go to the next slide now. So we saw so far is what is fault management, and we also saw what is the configuration management, right? So now let us look at what is the accounting management means, right? Accounting management, I will give you a simple example. Let's say you mobile, for example, mobile phone, you can buy a mobile phone with prepaid service or postpaid service, right? If it is a prepaid service, let's say that you paid 100 rupees and bought a mobile, some so much of talk time or data service, etc. Then someone has to monitor that whether that money is utilized. The moment 100 rupees is exhausted, then you should not be allowed to make further voice calls, or maybe you should not be allowed to do the data call. So there's another example could be the let's say that DSL broadband. When there are different packages being offered by the let's say Airtel or BSNL or something like that. Let's say you take a 4 Mbps connection with 40 GB plan. What does it mean is you will have a 4 Mbps connection speed, and the total volume which you can upload or download is 40 Gbps. Once 40 Gbps is consumed, there can be two actions. One is first of all, that 4 Mbps speed has to be cut to lower most speed, maybe 64 kbps. or it could be stopped depending on the service should be stopped, or it has to next billing cycle it will increase, right? So in this case what happens is there is a network utilization of the every byte in and out of that particular customer is monitored and then integrated with the billing system, right? In an enterprise environment you may not come across customer doing a billing type of for their users, and most of the time you may not find a billing is one of the applications required in the enterprise environment, and hence you do not have to worry about the billing. So we can skip this, it is not very important from the enterprise perspective, but if you are managing a telecom company, this billing accounting management is extremely critical, because one side you pull all the data of the utilization, and then on the other side you have a billing system. Depending on the prepaid service or postpaid service, you will have to implement the certain policies or make that accounting working, right? So let's now go to the next one, which is a performance management, right? What is performance management? The fault management and performance management are two different things. Many times it is looking closer, but actually it is different. There is a for let's say take a same example of a customer has a network. Yeah, when many times I may say that only network many times, but the entire NMS is not just meant for only to manage network elements, but it is also meant for managing the entire S4N products, right? So you can, when I say network, you can also replace that with S4N, like a server or operating system or the storage, various things as well, right? So let us say that customer has an application which is very sensitive to the latency or delay or jitter or packet loss or so certain parameter like delay or latency means how much time it takes for a packet to reach from location A to location B, right? And or jitter means what is the delay, what is the variations in the delay, like there is a maximum delay, there is a minimum delay, what are the variations, that is jitter. Sometimes the link may not be proper, it may be losing packets, there are some errors and noises in the what do you call that, in that particular link, and hence there are a lot of packet losses are happening, right? So that is another issues which you may come across, right? So then someone has to monitor for an application to work, which application could be video or real-time applications like voice, etc. So you'll have to monitor whether the network performance, like whether latency is okay, jitter is okay. That is one network performance related. There are also other type of things. What about the CPU utilization? Let's say customer runs a server, and server utilization is any point of time 85% or 90%. Does it go closer to 100%? Then what happens is server may crash, or maybe application may give a very, very poor response to the end user. So you will have to take care of those type of performance related issues and take some corrective actions. So there is another example, could be memory related issue. Let's say customer reports to you, the server crashed yesterday at 2 o'clock in the midnight. What exactly you will do? Because you do not have any data of 2 o'clock what happened. So that means you need a system which will capture all the data of various performance issues, like which could be related to the servers, CPU utilization, or the memory utilization, application level monitoring, like how many users were connected, what was the table size, was there a free space in the disk. There was several parameters needs to be regularly collected from the server and then made available through performance management. When someone says 2 o'clock I had a problem, system was extremely slow and people could not do any work, then immediately you should be able to go to the performance management and look at what exactly happened, what was caused the problem. Or sometimes what happens is performance management can also trigger a fault. What it means is you can set certain thresholds. Thresholds could be, let's say, whenever there is a CPU utilization, crosses 85%, notify to the NOC engineer so that he will look at various parameters and see whether everything is okay or not. So you can set certain thresholds levels for the performance management system to create fault also. So one, performance gives you historical data on a graphical, like maybe a map or something like that. You can see the in terms of a link, it can be what is the ingress traffic, what is the egress traffic, any point of time on that link, right? Maybe that data is every 5 minutes or every 1 hour. Those are collected and then plotted as a graph or a graphical manner and presented to you. Or it could be any other storage related things. So probably you like to know what is the IO person, number of IOs happening. So various storage related information you like to monitor and analyze, right? So the performance management, it collects the data from various elements in multiple methods. There are different set of protocols we are using to collect the performance management. Right now, you just understand the performance management is useful to collect various performance of network elements, performance of the S4N elements, and made available in the central place for you to look at what's happened in the past at a different time intervals. Sometimes performance management can also give you a trending report, a trend analysis report. For example, if it has a data for 3 years, and every 3 months or every 4 months, what exactly, how the users are getting added, what is the CPU utilization, how is the disk utilization happens, how is the performance when the initially 3 years before, what was the status, and every 3 months, what was the trend has happened. If this trend is continuing, in the similar growth is continuing, 6 months from now, 1 year from now, what will be the status, right? You can expand the server to more capacity, or you can order for a new server also, depending on what exactly going bad. So the trend analysis also very useful, which can be taken from the performance management. So now let's go to the next one, which is the security management. Security is, of course, I'm sure you are aware, security is extremely critical for the customers, right? The security can be done or required to be done at multiple levels, right? It is not security means immediately people think of a firewall deployed, and the firewall is deployed with a set of rules, right? Firewall is just deployed with maybe what is allowed, what is permitted, what is denied. Set of rules which is put on every interface, this direction and or opposite direction. So probably yes, that is one area of the security management. And after you deploy the all the firewall rules, after the firewall rules, you may also like to monitor the logs which are generated. Like for example, the firewall may generate some logs, like some attacks are coming, or some what are the denial reports, how much is traffic coming from where for traffic to get denied, etc. So those type of logs also it will generate. So that is also one of the things you like to monitor it. This is at a firewall level, but there is also the security to be done at multiple layers. For example, network layer security is much more critical. What I mean is, let's say some user walks into an enterprise customer and he finds a LAN point, right? He plugs in his laptop connected to that LAN point. Will he get an IP address, right? Will he get an IP address? Probably yes, because if the customer has not secured his network, customer has not put up some checks in place. Like for example, some of the customers, they deploy DHCP server. Whoever is request for an IP, it issues an IP. Once somebody gets an IP, they can access to all the resources there. Is it that level of security deployed there? Whoever asks for IP can get an IP, or what you do is you collect the MAC address of the users, right? And all the MAC address of the users are put in the central servers. Only I can assign IP address if the request is coming from these MAC addresses only. That is the second level of authentication. So that means it is not only DHCP. Then third level is it could be a username password based. Like only yeah, if this user, sometimes the hard resources are shared among many users, so each one may have a different username password. In certain cases, people will use two-stage security, like one is username password, second is they may use tokens, soft tokens or hard tokens, where you will have to feed in those values also, double authentication, triple authentication kind of things to access to certain critical resources. So you need backend servers which will have a user information or the hardware related information, who is permitted, who is not permitted, what are the security logs, etc. You need some system in the backend. Sometimes you will also like to have, customers may have multiple offices, each locations they may have different firewalls. Like you like to push certain policies uniformly. Or take another example is, let's say that is a threat management, unified threat customer has deployed, and they may have to have certain systems which will update the signatures, virus signatures or any kind of signatures on all the UTMs. Then only it is useful, because UTM is deployed but it doesn't have the latest signatures. It's of no use, right? So you combine collectively all of them together and put it in the central place to manage the whole data center network, various things. So this is all about security management. Yes, let's go to the next one. Yeah, this is about the summary, the fault management, configuration, accounting, performance, and security. So in short, you call it as FCAPS, right? FCA PS. So somebody asks you what is FCAPS, so you should be able to tell that. So fault is all about handling fault of the IT infrastructure. Configuration is all about managing the configuration, backing up the configuration, providing standard configurations to all the places, maybe software management, anything related is comes under management. The next one is accounting management. I had mentioned to you that accounting is more related to billing integrations. It is, I don't know whether there is any other enterprises has a practice of doing billing. Probably sometimes, what some locations, maybe IT becomes a service provider for the group companies, right? Based on the utilization, the individual group companies, IT may like to generate a bill and then provide to them. You use to so much resource, you use to so much resource, you use to so much resource, right? Maybe if they take an internet gateway, who uses how much bandwidth? Cumulatively, they may take a bandwidth which can be shared among different group companies, and they may like to generate billing. That may be a very exceptional case. Otherwise, you may not find any of the enterprises using the accounting management in their environment. Performance management is quite common, almost everyone has it. Security management is common. At a higher level, you will, if you will see, the customers will definitely have a fault management. If he is not having it, we can help them to set it up. Then second level customer will go for is performance management, then the config, then the security. The last one, probably in the importance perspective from the enterprise, is could be the accounting management. So this covers the entire FCAPS related things, and we just cover 2-3 more slide, and after that let me look at the questions which you may be put up, so that we, if there are any questions not answered, we can discuss that as well, right? Okay. Now I think someone need to be muted, right? So you just see, look at this picture, network management system. You have a network on the bottom, a cloud. The cloud has lots of elements, right? It has got routers, switches, servers, various applications. The entire cloud is an IT infrastructure of an enterprise, right? If this entire thing needs to be managed for that required FCAPS, you see there is lots of servers on the top. You have fault management server, you have a configuration management, accounting, performance, security, AAA. What is AAA? Is basically AAA is authentication, authorization, and accounting, right? Authentication in the sense a user joins and whether the user is allowed to access or not, right? or maybe his password is correct or not. So maybe it verifies the password, yes, he is authenticated. Second is authorization, like what is he allowed to access, right? So that is an authorization. And then the utilization, what is that, how much he has used. So that is all about the accounting practices. Most of the time you find radius servers or TechAct servers used for AAA applications. If you come across AD, Active Directory, etc., that is also one kind of a AAA only. Basically, it authenticates the users, right? The other one is syslog. Syslog is maybe all the different devices in the network. When there is a notification is required, there are multiple ways it can send it. One of the ways could be SNMP. The other method of sending that information is syslog. So you will have a syslog server set it up where whatever the events happening, it will send a log to the syslog server where you can go through the logs, right? Sometimes customer enables syslog for everyone who logs in and logs out. When somebody logs in, immediately a syslog message is sent. Somebody logged in at so and so time, and he logged out. So people like to audit that later on, who logged in and what he did. Also, there are some applications which are capable of monitoring what are the things the user did it after he logged in. So that is also can be sent as a syslog message. Then customer might have the service desk, basically trouble ticket management purpose. There is also asset management you may see in certain customer places, IT assets, right? IT assets could be hardware related or maybe software licenses and various things. So you may have an asset management which is also part of the NMS. And then there is also a TFTP server, which is fundamentally the backing up the configurations from the devices or load software, etc. So you do it with the TFTP. Some cases FTP server, some cases TFTP, or maybe both may be there also. Then you also see a NetFlow collector. We will see more detail about what is NetFlow collector later in some slide, where the logs which are generated from the different devices, various logs which are generated from the different devices. The devices can send periodically the data to the central server where it can collect those flows, like and then it can provide information to the IT decision maker about who is the heavy user, right, and which application is the highest being utilized. Like for example, let's say customer takes 20 Mbps internet connection for his entire enterprise. Let's say just an example, right? In the 20 Mbps, how this 20 Mbps is utilized? How much is the web traffic? Right? How much is YouTube traffic? How much is let's say Facebook traffic? How much is useful traffic? How much is time pass traffic? Right? So and who is a heavy user? So those type of reports, if he is looking at, then how is it possible? So the device sent the statistics or flow related informations to the flow collector. From the flow collector collects all these things, and then it can generate those reports. There could also be a next is a database. Basically this fault performance, all of them they may use in the backend, because it has to store large amount of logs, historical data. So in the backend it will require a database too. So all of them, all these devices, all these servers and applications generally kept behind a firewall, right? Because the NMS also, all these applications also need to be secure. In many places, you will find primary knock and DR knock. If there is a DR knock, DR stands for disaster recovery. If there is a DR knock is there, let's say that primary knock has failed, then how do we make sure that all elements are working or not, right? So then they set up a DR knock where they duplicate all this, different set of applications in DR knock as well, so that when there is a primary knock fails, they can still have the management control from the disaster recovery knock, right? Let's go to the next slide. Okay. You see this, there is a concept of NMS and EMS. So NMS stands for network management and EMS stands for element management, right? If you see the cloud, which is on the bottom, it is a multi-vendor network, right? So multi-vendor network means a network which is built with multiple vendors. It could be some elements from Cisco, Juniper, Alcatel, or various other vendors. All these vendors devices comes over there. That is one. Second is everything need not be the routers and switches, right? Something could be router switches. In some cases, it could be the transmission equipments. In case of telecom companies, you find let's say SDH elements, right? And sometimes your customer has an IPPBX that needs to be managed. Let's say that Avaya voice over IP system customer has got it, so that also require management. But if you really see these different devices, they may use a different type of method of management, because there may not be much standard, because there are certain things are standard, but there are a lot of things could be non-standard proprietary way of managing the that respective vendors, right? We can't say that Cisco devices management is equal to Alcatel management equal to Avaya management equal to Ericsson, right? So each one could have different ways of management, right? So what they do is they insert a layer called EMS, element management, right? The respective vendor, vendor A, vendor B, which is written on the picture, each one gives its their own NMS or their own EMS, element management system, which manages their own devices. That is on the south side, that is on the bottom facing, and north facing or maybe the top facing, it could be a standard interface, right? It could be standard SNMP or any other northbound interfaces are possible. South side, it can have a proprietary kind of interfaces to manage those elements. So that is one method of differentiating NMS and EMS. There is also, you see, a data line connecting multi-vendor network with NMS. So what is the data line is today more and more IP elements, devices managing through SNMP, etc. They are more and more becoming standards. So because of that, what happens is you may not find a EMS presence in many places. There may not be any EMS at all. It's a mixed scenario. For some vendors, some kind of devices, you may have an EMS, and in majority of the cases, all elements are directly managed from the NMS without an EMS also. You may see both scenarios as well in the field, right? Okay. So there is also the 5-layer TMN architecture, right? So maybe after this, we will have a logical break to go through the questions. So the layer consists of, if you see the bottommost layer, NEL is written, network element layer. Network element layer means it could be switches, routers, all of them are on the network element layer. And the network element layer is managed by EML. EML stands for element management layer. That is those EML layer manages the network elements which is on the bottom. Multiple EMLs are managed by the NMS, that is NML layer, right? You see the NML layer on the top. So you see these 3 layers in mostly in all the customer places. But in certain complex scenarios or maybe critical applications, like maybe more specifically is probably a telecom type of environment, you see 2 more layers, which is SML, service management layer, to manage the service quality or bringing a new service over the network through the NMS and the EMS. So you may have a service management layer, maybe a customer portal. A customer comes and clicks a bandwidth, right? Let's, for example, when your bandwidth consumption is completed, let's say you ordered for certain bandwidth with Airtel, and let's say 4 Mbps of bandwidth with 50 Gbps of quota, and 50 Gbps is consumed, immediately 4 Mbps becomes 64 Kbps. So movie and various other applications require more bandwidth, it doesn't work properly. But the customer provides you a portal, right? You may, if any of you are using Airtel, you will know they send you a link that this link is you go there and order upgrade your bandwidth, right? So it's a customer visits that particular portal, feed in his login credential, and then he increases the bandwidth. And basically, he is enabling a new service even before the next billing cycle comes. Then what happened is that's a service management layer. That service management layer trigger the NMS and maybe in case EMS sometimes. And finally, network elements are configured to have a higher bandwidth delivery to the end users. So this is about the service management layer example. On the top, you see the business management layer. That is a business management layer deals with maybe return on investment or market share related information, etc. There's a higher level people will be using, and they will take lots of information from the service management and create business management or business reports, right? What the employee satisfaction, what the customer satisfaction levels, how much we revenue generated through SML layer, so for informations it is taken from the SML layer. This just basically giving you a picture of how the right from network element to the NMS to the service management to BML, how this entire thing is structured. Earlier we saw another layers, 5-layer design, what we saw, that is fundamentally FCAPS. That is one way of defining the layered information. This is a different way of looking at the NMS layer. Now let's go to the next slide. Where I'm going to look at the chat window now. If there are any questions which are not answered during the discussion, I will answer that. Then we go into then we after that we will start the protocols and technologies, right? So are there questions which are not answered? Let me have a look. Chat window. So someone is asking, is there a demo? But there is no demo. We are not doing this demo. Today is TMN is what is TMN? Telecom Management Network, right? That is that's the TMN stands for that. Then I think that's all. There is no other questions. There is no other questions. And okay, now let's proceed to next chapters. No need. No, don't unmute, but they can only because otherwise it's yeah. You can put it on the chat if you have a question, and we can answer them. If there is no questions, then let's continue to the next next topic. Bhupinder is asking bottleneck or hotspot. I don't know what is the question. It is only question mark is there, but there is no question actually. What is bottleneck? What is hotspot? What you'll have to ask the question. I don't understand what is the question. Question generally starts with 5 W's and 1 H, right? It has to start like that. If you that's question, right? Is a flow command in NMS vendors. Okay, we will talk about the flow related things going forward. I have some slides on the flow. Just hold on for some time. Okay, I think there is no other questions. So there is someone has put example of NMS software available or popular. Okay, the examples of NMS software someone is asking. See, our Maestro is one of the NMS. It is developed by HCL, and I understand there are 40 plus customers across India. They are already using our NMS. The most popular NMS is HP OpenView, and there are other, that is for the large enterprise, generally they deploy. Small enterprises, they deploy softwares like SolarWind, then PRTG. There are a lot of free NMS also is available. And from our iTalk perspective, what we are deploying is CA tools. That is CA NMS. If you search on the Google CA NMS, then you will know a lot of details. We have some slides, some slides about the CA as well. So someone is asking to repeat the NMS and EMS. I don't think I'm going to repeat that now, but however, we will send you the recorded link. This entire thing is recorded as well. You have to go through that if you want a repeat session. But if you have a question, please do type it. Okay. I'm going to the next session. We will talk about protocols and technologies. Okay. So the next break time, we will look at the chat window again if there are further questions. But right now, let us proceed, right? Communicating with the network, right? Managed network elements, that network elements are waiting to provide us useful information. What it means is all the network elements, which network elements means today everything is a network element. You can say server is a network element, application also treated as a network element. They all have lots of information waiting waiting for us to ask for it. So when the moment NMS asks for give me this information, it immediately it provides. So once you configure all this real-time data, useful information which is related to fault performance and various areas which FCAPs, it is available already and it will be pushed to you. So network management always begins with understanding of how to collect and interpret this information. So the elements push some information, but what you need to do is you'll have to collect this information using the appropriate servers or applications, and then you will you can interpret what is that message indicate, right? So it's all about, that's the beginning of the NMS, right? So now let's go to the next slide. This is about method of gathering information. Fundamentally, if you want to gather some information from the network, how you do it and what are the protocols available, right? When I say you, it is maybe manually initiated or it is a NMS driven. If you have to go and collect some information, what do you do, right? What are the protocol exist? Okay. The first and fundamental thing is if the device has a console, log into through the console and then collect whatever informations are there, right? So some of the network devices will have a console port where you can connect a console and then get it. And all the servers, they have a console, right? So that you can, from the console, you can get lots of information, right? And the security is concerned, generally you should know the username passwords on the back end, it gets authenticated, right? The second one is you don't go to console because console require physically you need to go to the device to have an access to the console where you can do a remote login, right? Remotely you can maybe you can use telnet or you can use SSH to access to that device and then get whatever the information is required. The third category is many of these devices which we would like to manage. Today they support HTTP as a protocol. So if you go to that HTTP with that device IP, and it opens up a web browser through which you come to know a lot of performance or configuration of related information. So this most of the time you will see this HTTP interface supported right from your smallest device of DSL modem. Let's say if you have a DSL modem which you like to configure, it supports, there is a built-in web server in the DSL modem. So you access to that browser and then put that whatever the required configurations, or you can look for certain information. HTTP is one of, and most of the routers, switches, and many applications and servers, they support HTTP as an interface, right? The last one is the SNMP, which is a much more powerful, most widely used across all the S4N devices. The SNMP is a very popular protocol, and there are versions on the SNMP. Version 1, version 2, C you written. Basically, version 2 came and it got improved with certain additional features. It became 2C, and then SNMP version 3 also. So we will see this SNMP little more detail going forward. So this can using SNMP as a protocol. SNMP stands for Simple Network Management Protocol, right? SNMP stands for Simple Network Management Protocol. Using SNMP, periodically you can collect the information from NMS or even manually initiated also using SNMP commands. You can collect informations from the elements, right? So this is fundamentally you go and collect directly, or you collect through NMS data from the network. There is another method. I'm going to the next slide. Okay. Another method is, let's say the device has to push the information, right? You are not collecting, you do not know whether this should be collected or not, but when there is a fault occurs, the system sends you an information. It's a most of a system initiated. It is not you are initiating. System initiated communication with the NMS or to you, the user interface. Some of the protocols used there are syslog. Syslog is always system sends it when there is an event happens. So that is syslog is one of the methods. NetFlow is another. NetFlow is mainly used for accounting. Accounting, we have seen in an example in the past, a 20 Mbps internet link. An IT manager wants to know what is the utilization of this 20 Mbps in terms of protocols, in terms of users, in terms of a set of websites people are going. So he wants to have that information. Then that information can be generated or retrieved using the protocol NetFlow. You enable NetFlow, enable it on that particular interface is connecting to that internet, then it starts sending continuously flows, and you need a flow collector which collects all these flows and then generates a report. So that's it's a device initiated. Then there is something called EEM, Embedded Event Manager. See, fundamentally, an EEM is kind of script, set of commands to be executed, set of or an action to be taken in the event of an event happens in the device or it happens in the network. Let's say that there is a you want to bring in some automation. Let's say so when there is this particular trigger happens, or if this particular failure happens, or if this particular level of utilization exceeds this particular threshold or something like that, what is to be done, right? One, you can take manual corrections, right? Because you got a notification, you can do a manual correction. Second is you can also write certain scripts which will go and fix the issues, right? So that is also is possible using EEM scripts, right? So that is another method. The last one is the SNMP trap, which is much more popular and widely used. Using the same SNMP as a protocol, the earlier slide what you saw is NMS going and collecting the information using poly. That is NMS initiated, whereas SNMP trap is device initiated. Let's say there is an temperature goes very high, or fan has failed in the device, fan failure. It has to send a trap, fan failed. So that means immediately the NOC engineer who is looking after this, he can open a trouble ticket and then somebody go and fix it, right? Let's say otherwise what happens is the fan failure notification has come, and it is not, it's a device is reporting now. It's not customers calling you and telling, right? Now the device has reported fan failure, and you can also do auto trouble ticketing from the NMS. You can integrate with your service desk or help desk to create a trouble ticket automatically also is possible. So there, you can have, once you receive the SNMP traps, then you come to know there is a fault has happened. Then you can of course take certain corrective actions. This is event driven and device initiated. It is not the user initiated. User of course will take corrective actions based on the information he receives from these devices. Okay. How are we doing on the time? How much time we have now? How much? What's the time now? 11:14. 45 minutes left. All right, no problem. Because we may take 1 hour more or 1.5 hours more. We may need to extend it for about 1 hour 15 minutes more. Yeah, yeah, sure. Okay, so we have done only 19 slides. We got 71 slides to go, right? Okay, so this is the, maybe we go little faster going forward so that we are able to cover more in the given time, because I know I'm holding most of you where you are on compromising your customers major issues, etc. You are attending this session, so let me go little more faster so that once we have the fundamentals right, then it is easy to grasp faster as well. So you see here there is an SNMP manager and there is an SNMP agent. The network devices on the right side, if you see, there is a router, for example, or maybe a LAN switch, or maybe a server. There is an SNMP agent is there. It is a piece of software, small piece of software which runs on the device itself, and it collects the statistics of various parameters. So all these things are the job of the SNMP agent, which collects all this information, keep it ready. These informations which are collected, they are all available in the MIB, and which is also part of the same software SNMP agent, which is these two, while you see it separately, it is basically, it is inside the router. So all these informations are there inside the router. And whereas the SNMP manager fundamentally, which does the FCAPS related things, which is using a communication with the network device using the protocol SNMP, and collects this information periodic basis and pushes to the database. And from the database, you have lots of report generations, various activities are possible later sometime, right? So fundamentally, it's a two-way communication. Sometimes you do polling using SNMP. Sometimes device is sending you a trap. It's a device initiated, sometimes NMS initiated. So that's why you see a two-directional, marking on the SNMP. So the presentation, where is it? It is gone. Is it? You can tell them. See, there are some problem. Looks like a presentation got deleted in the bridge, and we will. We no, we can present it directly from the my PC, no, right? Just hold on. We are trying to fix this problem. Just give us 2 minutes.
Yeah, everyone, please, sorry for the interruption. There is some technical issue. We'll be coming back soon.
Uh, yeah, thanks, Akhil, for quickly fixing the issue. So let us continue from here. We just saw this particular slide. Let's go to the next one. Uh, Okay, so little more detail. The SNMP manager has a database, and manager is responsible for FCAPS. What is FCAPS? You are all familiar already. We have done enough discussions. Let me go to the next slide. The agent is on the right hand side. Fundamentally is a software running on the device, which is responsible to collect all the informations and send the data to the SNMP manager using a SNMP protocol. Okay, and this entire information which is there on that the MIB, they are all stored in a particular format, right? So before that, I just want this particular slide. The what is trap, right? Trap is fundamentally the alert sent by the devices to the NMS. So one I is told, one is polling from the NMS polling the device, or second is a device sending the information to the manager without even it is asked for when there is a fault, right? So that's a trap. So the both information both are done by the agent, right? Now let's go to the next one, which is the MIB. MIB is the one which is the database of the SNMP agent. See, all the information is collected, they are all stored in the MIB. And SMI, right, that is a structured management information. They define the how the SNMP, the entire data to be stored, right? So the SNMP is a standard protocol used with almost all the vendors, right? It could be, you can use the same NMS and to manage multiple vendors, multiple categories of devices, as long as that particular device supports SNMP as a protocol. So that means you do not have to know Juniper commands, how to configure Juniper, how to configure Alcatel. You do not have to know. As long as you know SNMP, you can collect all the information from multiple vendors. So that's the beauty of the SNMP, right? So that the entire structure, how it has to be defined, they're all defined by the SMI, right? So you don't have to really know every vendor product or every servers, every application to manage that. All of them are standards from the SNMP point of view. The structure is defined as a structure. ASN.1 is a language through which this entire structure is defined. We'll be seeing this little more in detail. What is how does the structure looks like? Fundamentally, how the data storage happens in MIB, and when MIB informations are sent to the SNMP manager, let's say it is giving an information about 5.3.4.7, how do we interpret that in the NMS point of view? So that is basically the ASN type of language in which the entire informations are sent. So you'll see that in the advanced trainings. Right now you can be aware that there is a MIB, which is a MIB is a collection of managed objects. There are multiple informations which you will be collecting. Each information is a managed objects, and all of them are collected and stored in the MIB, and the SMI structure is used, and the language is ASN.1. We'll see this in detail later in the advanced training. Okay, now let's look at the two-tier management, right? What is two-tier management means? So there is an NMS on the top, that is SNMP manager or some kind of devices manager on the top, and then there is a which has a database too. And on the bottom layer, if you see, there is a management element and the agent, right? So there is when the devices to be managed, so some informations are there in the network managed element. They are all stored in the agent, and that is made available through the manager, and from the manager you look at the through the manager console or something like that, you look at the entire statistics or the performance or fault related information which are coming from there. So in this structure you see there are two layers are involved. One is the network elements, which has an agent. Other one is the manager layer. So this is fundamentally the two-layer management, right? So that is one two-tier management. Sometimes you will also come across unmanaged elements. Unmanaged elements means there may be customer using the the LAN switches which are not manageable. It doesn't have an IP address or it doesn't have a SNMP support. If that is the case, you can't even manage it. So to manage the element, minimum most it should support is it should have an IP address. If it has to be pinged and checked, then it should support SNMP to collect the utilization and various performance data. And you will come across lots of customers switches, particularly the user switches, where the users are connected. So they are all unmanaged type of switches in some customers. I had visited sometime in the past to a customer Thermax. They had a lot of unmanaged switches, right? You don't, that switch doesn't have an IP address, doesn't support any kind of SNMP, right? So customer wants that devices switches to be managed from the master NMS, right? How do we do that? The challenge, right? So you'll have to be very careful. What is that device can be managed, what cannot be managed too, right? The next one is three-tier management, right? The three-tier management means there can be a proxy agent in the middle, or there may be an arm probes in the middle. If you look at how we are managing the, let's say that I talk how we are going to manage the customers, right? So there are customer elements, right, and which has an SNMP agent, and there is a collector or probe which we will be fixing in the maybe a PC loaded with some set of software. That will, all the devices will be configured with the SNMP server as that particular PC. Sometimes it is called hub, some places it's called collector, or you can call it as a first level manager. So all the SNMP traps and SNMP informations, they are all sent to the local server, and the local server is integrated with the ITOC NMS. So there is a three-tier management. So that also you can relate it, right? So you have an NOC engineer of ITOC. They connect to the ITOC NMS. That ITOC NMS connect to the customer NMS, and the customer NMS connects with the network elements which needs to be managed. So you see three layers in the middle for the managing the element, right? Let's go to the next. Okay, how does the SNMP message and PDU? So PDU stands for Protocol Data Unit. Fundamentally, it is how does the packet looks like SNMP message is concerned. Sometimes past we saw there is an SNMP has a version 1, 2, 3. So when there is some SNMP message is sent, it has to mention what version it is. And security informations like SNMP will have certain security like password or encryption related information, etc. So that is another information. And then after that, actual SNMP commands and then responses, right? So that is part of the PDU. So this is the message header of the SNMP. How does it look like? Now let's see some of the SNMP. How does it work? So there are few commands. One side the manager is you see is it a blue color or green color? So they talk to the agent which is yellow in color. So SNMP manager gives a command get command, and there is an agent response, right? Gives a response to this. This is one type of PDU. And get, that means it gives a particular value. So this may have managed objects, hundreds of managed objects. When it needs the second object, third object, fourth object, etc. Okay, it is vanishing. I will directly present it from my desktop, right? I do not know why it is doing like this. No problem. I will share my desktop. There is no time for now. Nobody can delete my presentation in my desktop, right? They can delete it in their server, but not in my PC. Sorry, there is some technical fault happening because the file is disappearing. Now I shared my desktop, right? So can somebody confirm that they are able to see the my desktop shared already? Can somebody type it on the chat that they can see the Yes, great. So you are all able to see this. Now you are directly seeing it from my desktop, this particular file. So you have a get and then there is a response. There's a get next and then there is a response. So get next is get the next data, next data, next data. Every time it has to ask. So the next data is sent from the agents, right? So that is a second method. The third method is set. The set is fundamentally you want to set certain parameters on the agent. So you that is a set is another command. Then there is an SNMP notification. You see the arrow also accordingly. You see is enable full screen, right? How do we enable full screen? 1 minute. Somebody is asking me to enable the full screen. Team, just manage right now because we are facing some technical faults. We do not know what is the reason. Maybe this is a maximum you can get it right now, right? Just a minute. No? No, no. Yeah, this okay. Yeah. So, am I audible now? Can you hear me? Yeah, I can. You can hear me, right? Yeah. Yeah, I think now you are able to hopefully see the full screen. We saw some SNMP commands like get command, get next command, set command, and SNMP trap command, right? So the next one is a set of commands are get bulk and response, right? Get bulk means instead of get first object, second object is done using get next and then first and so on. You can do a get bulk, one bulk command, you can get that the entire MIB downloaded to the NMS. So that is the next way of doing it. And the last one is the some of the information that is inform type of things, right? So that is another command which is done here. So from the just putting all together, so from the manager to the agent, you see get request, get next request, get bulk request or set request. So these are all going from the NMS to the agent. The response is coming from the agent to the NMS, and there is a trap which is coming from the NMS, that is agent to the NMS. So this is the direction of the flow as well, right? So just putting all together SNMP version 1 and version 2. In fact, version 3 uses exactly same as version 2, but it has just got additional security related things. We will see that in the next slide. So you see get request, then SNMP v2 is concerned, it has got the get bulk request. Get bulk request is not supported by the SNMP v1. Then inform request is not supported by SNMP version 1. But generally you will find SNMP v1 is not popular, but SNMP v2 is widely used. This is a direction and descriptions of these SNMP PDUs, right? So there are some more differences. Additionally, we just see what are the additional differences. SNMP v1 version 1 is the first version, and here it uses the counters are all 32-bit counters. What is mean 32-bit counter is, let's say you will have to see the utilization, right? What I mean is bytes in, bytes out of individual interfaces. And if it has to be just a counter, it has to be in binary terms. It has to have the counter value is very, very important, right? Whereas in a 32-bit counter, it may be yes, only a small set of data can be shown. Its maximum bytes it can show is 2 raised to 32. But if you see your interface capacity is 1 gig and it is full, the full traffic is going in that. Now there is also devices coming with a 10 gig interface and also 100 gig interfaces. Then 32-bit counter is quite small. You see 32-bit, what you see here is 32-bit counter. In 34 seconds it will roll over. It will come back to 00 and then again it starts and then goes to the all ones, right? All 32 bits are ones. So that's when in SNMP v2 they changed this into 64-bit counters, right? So from 32-bit it has become 64-bit. And then in SNMP, the community, basically community is something like a password, because only who has the right community will be able to collect the information from the agent, not that anybody who knows the device IP can collect the SNMP data, right? So those are all the community values are set in plain text, both in v1 and v2, whereas in v3 it is basically the encrypted. So somebody taps the data, they still will not be able to find out what is the password being set to collect that information from the devices, right? So that's a difference between v1 v2. v3 is almost same as v2, but however it uses the encryption and also authentication it uses, whereas here the SNMP v1 uses just a plain text. As just plain text means somebody taps can easily see what is the password, right? Okay, just putting all v1, v2, v3 all together, you see what are the differences. SNMP v1, v2, v3, there's a levels and authentications and encryptions, right? So no auth, no PRIV. So this is basically privilege levels, means that there is no authentication, no encryption. Auth and no PRIV stands for messages are authenticated but not encrypted. So you can have different combinations here. So during the configuration, so whatever you configure, different devices can have different type of methods. Some devices configured with SNMP v2, some devices with SNMP v3, some devices with the SNMP v3 only authentication, no encryption. Some are configured with authentication and also encryption. You can have any kind of combination, different devices, configured based on the features supported by the device. And accordingly, what is more important is accordingly the same configuration should reflect in the NMS side, so that the NMS, when it communicates with that device, it finds out what version it is using, what is that encryption, logic it is using, etc. Right? So that is the method of the SNMP, right? Okay, I think having spoken on the net flow, SNMP, let's now understand what is net flow as well. On the net flow side is concerned, as I mentioned earlier, the IT manager may like to know the utilization of the pipe, which is 20 Mbps, what is going on, etc. So that is possible by taking the flow accounting. Flow accounting, here there is an example. Let's say 10.0.0.1 doing a telnet to 10.0.0.2. So that means here you see there is two flows are active. One is from left to right, other one is right to left. So you would like to know what is the protocol and how much is the data transferred from left to right and also right to left. So this is basically an example of flow. And now you see the next example is simultaneously two activities happening. There is a telnet and there is also ping. So that means the number of flow becomes four numbers. On all the four numbers, you like to know, total bytes and what is the port, source port, destination port, what protocol it is, and how much is the data. So the moment you enable NetFlow, it has to account for all the flows which are going through that. Imagine there is a 20 Mbps of link, and all the 20 Mbps may being consumed by, let's say, 1,000 users, and each user is using average of 10 flows. Then you can imagine about total number of flows any point of time will be active. Some many times just switch on the PC on the network, you will find nearly about 10 flows are active, right? You don't have to do anything, just switch on the PC, 10 flows are active, because there may be some applications which are running here, it will like to sign up somewhere, and then some communication will happen, because some of the preloaded some of the applications flows will start there, right? So that is what is the flow is all about. Now doing that 100% accounting using the flow, it is many times big challenge, right? Because router is meant for routing, but now router is expected to do accounting of every flow. The CT may not have so much power to do accounting of every packet flowing through that. So what they do is they enable some kind of samples, maybe 1 in 100 packets, that is 100 is to 1 as a sample. Sometimes 1000 is to 1 if it is a bigger pipe, 1000 is to 1, and that means the accounting required not for all the packets but for samples. Every 1000 packet, one packet it will be taking, it will do the accounting. And then similarly all this accounting informations regularly online it pushes to the flow collector, and flow collector now it has a picture of what are the different flows going through the routers and from where to where and what applications, what are the port used, etc. From there you can generate reports on utilization of the pipe, how the pipe is being used right now. So that is an application from the flow perspective. Okay, now what I already explained is given here, source IP, destination IP, source port, destination port, protocol type. TOS is fundamentally used to map the QoS, because TOS is generally a 3-bit. You can 3-bit 2 raised to 3 is 8 levels of QoS is possible to configure. So that is an 8 the QoS information, and of course the interface also. So these informations are accounting enabled on the devices. These information NetFlow accounting, once you enable, are pushed to the flow collector for generating the reports, right? What do customer do with NetFlow? Traffic analysis, mainly the traffic analysis, sometimes billing and accounting. Sometimes they use it for anomaly detection. Anomaly detection is fundamentally, let's say there is a attack happening on the customer's website, let's say. Let's say there is a bank where some huge attacks coming from somewhere to that website. What will happen? Say, let's say the server is sized to handle something, so maybe concurrently the server is sized to do 10,000 flows or maybe 50,000 flows, and somebody is attacking from somewhere with 1 lakh ping packet to the server. Then what will happen? The server has to respond, of course. Then the banking servers who wants to do the online transactions, they will not be able to perform, because the server is busy, heavily loaded. So that means you like to know the from where the attacks are coming, which IP the attacks are coming. Those type of things you like to know. So that information can be taken from the NetFlow, and appropriately you can enable the firewall rules to block those IP addresses. That's the one of the application of anomaly detection. The next one is capacity planning. Of course, once you know that this is the traffic being used in my pipe, then you can plan better, right? So like this is my total capacity. This is the different set of applications. When the customer is adding one more server, one more applications, he can know that how much pipe is free, which application he can reduce the utilization level, and how using different methods, using QoS, using firewalls, various methods, he can do the capacity planning and add more applications as well, right? Okay. So now we talked about different protocols used. The key protocols are the SNMP, NetFlow, and some of the other protocols which are syslog we talked about. And these are the three main protocols you just need to remember. Rest of the things we will learn when it is actually required. Now let us now look at how to configure this on the devices. I'm just going through a set of commands which are required to be configured. So what I do is, let me look at the chat window if there are any new questions before, because this logically we are getting into the next topic of how to configure the devices for enabling these protocols. If there are questions, so there is about 30-second window for you to type any questions to answer. Otherwise, we'll push to the next topic. 30 seconds starts now. So there's a question, what is toss bit? Just do a Google search on what is toss bit. Fundamentally, it's part of that IP packet. You will find the 3 bits reserved for toss, which is QoS purpose. I'm not remembering what is toss bit, but probably type of service you can right now you can consider. But I'm also requesting you to verify through Google. Can you repeat MIB? No, repeat is not possible, but you will have a video link, recorded link, which for you to go through that. Yes. Terms of service, is it? Okay. Right. Fundamentally, it's a QoS related kind of things, right? So we are not repeating because we have a lot more to cover in the next half an hour time. So we are not repeating anything. But for you, you can see the video recorded link, right?
So if anybody want the recorded video, please send a mail to scledu@scl.com. We'll be sharing the link and you'll be able to download the video.
Okay. Okay, fine. So now let us now look at the so different parameters which we have understood: LAN, WAN, voice over IP, high availability, QoS, SNMP, MIB, fault, configuration, NetFlow. Lot of jargons so far you have been listening. Now let's see how do we enable that. So this particular thing is giving you an example of how to configure, but it is someone who is familiar with configuring the devices like routers, switches, etc. They, by looking at this, they will be able to configure it. I'm just not getting into explaining individual lines which are here. So basically, if you have to look at here, you put a community name on the configuration below, community name for read-only purpose and read-write purpose, and you enable trap. And when the trap is enabled, the devices should know who is the SNMP server, because it has to send a notification which server it will send it. And so you'll have to put that server, IP address and the community server string. And your device may have multiple interfaces, right? It may have 10 different interfaces, right? In the router, each interface may have an IP as well. So then, what should be the originating IP address for that SNMP message? Generally, people use the loopback interface as the SNMP trap as from where it is originating that SNMP, right? So this is a set of commands, but you don't have to really worry now, because when you configure Linux machine, the parameter you need to look at is you need to put that read-only community, you need to enable the trap, you need to know where to send the trap. and what is the originating interface, which is a loopback. If there is if the device has only one IP interface, that IP interface is taken. If it is a more than one, then depending on some logic, it may take some default interfaces IP. But otherwise, you want to force certain interface IP to be used, then you can set that also. So someone who is already network trained understands how this can be configured into the router, but other people don't worry. But you just remember right now saying that these are the parameters we need to configure for enabling SNMP on the devices which we need to manage. Now NTP. So what is NTP? NTP is a protocol, network time protocol. Let us say that example is let's say the devices are running 5 minutes faster than the NMS server. Okay, yeah, the local time in the device is 12:05. The NMS time is 12 o'clock. Let us say, for example, and let's say there is a fault has happened. The device sends an alert. Obviously, device sent an alert with the local time as a time. So NMS receives it, saying that there is a fault occurred, but it's like time is looking futuristic. Another 5 minutes, this fault is going to be happening. Or if it is time is reverse, let's say that device time is 5 minutes lagging behind the, let's say, the NMS time, then you will actual failure has happened now, but it is reported as a failure has happened 5 minutes before, right? So that is also not good. So you need exactly all the devices across the network, all the servers, all the devices having the exactly same time as NTP, aligned with the NTP server, including the NMS server. So normally what customers do is they designate a server as an NTP server, and that NTP server IP is put on all the other devices and servers. So every server, it takes the time from the NTP server as the same time. So that means across the customer IT infrastructure consisting of a data center, entire S4 technology, etc., everything will have the exactly the same time with not even a accuracy of millisecond difference. It will have the exactly the same time. So that is about the NTP. So to configure NTP, of course, from the device perspective or a server perspective, you need to put the server IP, which is my NTP address, what is my local IP, whether I can update the calendar also from there. And there is a time zone also. Here, example, you see PST, but generally you say via IST. And India, it is from the Greenwich, it is plus 530 hours. So you said that. Then after that, the entire NTP is set with that particular address IP which you have mentioned. The next one is 1 minute. Let me change the slide. Yeah, syslog. As I have mentioned in the past, syslog is a device generated information going to the NMS server, right? So that means you will have to enable the logging of the syslog in the device, and then you need to say, mention certain IP address where the syslog needs to be sent. As you saw in the sometime in the past, there's a customer infrastructure has put as a cloud, and the NOC is put with various servers, right? Each server could have a different IP address, so you need to put where the syslog message needs to be sent. So once you do that, then whatever events happening, the message can go to the device as a syslog message, right? So remember, the syslog is fundamentally a text message, right? ASCII text. That means it's readable. You go to that syslog server and you can look at, you will find a message from different devices which are coming up there. When if you enable, let's say, for every user login, logging message has to come. XYZ user logged into so and so device. Immediately a message will come in this syslog server. The NOC engineer can monitor this regularly and see the corrective action. It can be useful for any kind of fault performance related issues also. Syslog can come, or later point of time for any kind of auditing purposes, who logged in which device, what time, those type of auditing purpose also syslog message can be used, right? And SSH fundamentally is for the remote login purpose, but it is secure than as compared to the telnet type of things. So you like to remote login to a particular device, then general practice is to use SSH. How to configure it is provided here, but however, you don't have to worry now, right now, what is this command, etc. But you just remember that this is also is required when for an NMS to be enabled, NMS to be managed, the devices IT infrastructure of the customer needs to have an SSH as well, configurations as well, right? And telnet is a simple one. If you have access to the device using telnet, then the device would have the telnet enabled. So this is another one. CDP is a Cisco discovery protocol. Fundamentally, if you do not know who are the IPs, etc., around it is connected, you enable CDP, then you will know who are the devices which are connected. Basically, CDP is a broadcast kind of protocol through which it can discover the neighbor devices which are connected. So one way of discovery is customer gives you a topology diagram, and in which from this what are the devices connected you are clear, understandable. In some cases, customer doesn't give you a network diagram. You need to assume and build a network diagram. So what you can do is you can go to the CDP and the CDP neighbors, and there are a set of commands are there. Once you view that, you will know who are the devices connected and what is their IP address. Once you know their IP address, you can try to rebuild the network diagram. And if you know the username password, you can tell them to that device as well, and get further access, right? So that is also is possible using CDP. Okay, so NetFlow configuration. I think NetFlow related information. What is NetFlow? Why it is used? What is that NetFlow information contains? We discussed earlier in the past. NetFlow also has got like SNMP has version 1, 2, 3. NetFlow also has got different versions. Different versions. The higher version has more enhanced features and more informations are sent. And fundamentally, you'll have to check what version of NetFlow the device supports, and accordingly the flow collector also to be configured, right? So how to configure the net flow on a router? Basically a command to be enabled on that particular interface. Here you see route cache flow. NetFlow is more specific to Cisco, and since Cisco, more than 85% of the enterprises use Cisco, and Cisco is very relevant to us. But there is also Juniper users JFlow, just like Cisco uses NetFlow. Juniper uses JFlow, and there is Alcatel uses CFlow. Someone else, there is some kind of flow supported by almost all the network vendors, right? And obviously, when you are enabling NetFlow, the device needs to be configured to inform where is this flow to be sent, right? So obviously, you'll have to put that IP address, and you'll have to mention what is the flow version, basically the format in a kind of thing. And the flows server, NetFlow collector, will run in a particular port number, right? So what is the port to which this has to be sent? And not only configuring this, if there is a firewall in the middle, let's say there is a network device, and there is a flow collector, and there is a firewall is there in the middle, that firewall should be enabled with the this particular port is allowed, so that the flow collector sends the log there. Otherwise, firewall will block. It is not only for NetFlow, even for SNMP to work with the performance management or network management, etc. The appropriate firewall rules has to be defined. Otherwise, what happens is SNMP trap will come, but it will never reach the NMS server. It's somewhere in the middle, it is blocked. So you have to see that end to end. If they including the firewall, it is permitted to reach, right? That informations are permitted to reach the SNMP server. Okay, so prerequisite for network integration with NMS. What is the prerequisite? Before putting all this type of configuration like SNMP management, SNMP, NetFlow, or NTP, all those things, so fundamentally first you need to check is whether the network element and the NMS are they able to reach. Is ping is successful? Is trace is successful? If this is not successful, don't even get into the advanced configuration. First, to make sure that your reachability is there. And then second is ensure that firewall is enabled with the required policies. Otherwise, you will be thinking that the problem is device configuration, problem is NMS configuration, whereas actual problem maybe exists, firewall is not enabled with that kind of required policies. The third one is coordination with the NMS team, because you may be in the field configuring a set of LAN switches and routers and servers to work with the remote NMS. But if you need to talk to them, I configured this, are you able to view this? Are you able to get access of these devices from the NOC? The coordination is extremely critical. You can't just simply go and put certain configuration and come out. Whereas the NOC engineer should acknowledge, yes, it is working now, because there may be some more additional configuration required, password or whatever, so the matching configuration is required to make the devices managed from the central place, right? So you will have to coordinate with the central place when you are actually in the field to configure some devices. Very important is you should have a good planning document. A lot of people are extremely good people. They do entire planning on their mind. On the paper, nothing is there. So when they forget after some time, and after that they try to, what is the password I configured? There is nothing is documented by them. That's a very, very bad practice. Remembering is good, but it has to be documented, right? So that's a good planning document is very, very important. And of course, use of Google whenever you are stuck. So whenever you do not know what is TOS stands for, or what is, because there are a lot of terminology, we use it on daily basis, we do not know what is it stands for, or we do not know how CDP works, or we do not know some XYZ function, how does it work. Use Google effectively and learn, right? So the Google is the best teacher for you when you are stuck, whenever you are stuck. So let's go to the next one. Okay, so we talked about the general NMS concepts, then for FCAPs fundamentally, then we talked about the protocols, then we talked about the how to enable them. Now we are having a 3 more topics quickly we run through. These fundamentally, what is ITOC, and then some of the NMS kind of things, right? ITOC is fundamentally HCL IT Operations Center, is providing the remote infrastructure management. The picture what you see is in architect view. Exactly same thing is getting built in Pondicherry. So someone who has visited Pondicherry in the recent time, they understand how does this look like. There are certain things not implemented yet. The televisions what you saw, probably it will take 1 or 2 months more to fix it. These televisions, basically different enterprise customers, FCAPS status will be real time monitored there. There will be set of NOC engineers who will be looking at the screens for their required enterprises or trouble tickets to fix those, customers, performance related or fault related issues. So this is what we are building. It's a world-class NOC. Whenever you get an opportunity, please do visit. And I'm in Pondicherry. Whenever you come here to meet me, I can take you around this facility to show you this, right? Okay, let's look at, from the HCL organization perspective, we do integrated support with right from the remote management to on-site, right? So on-site, if you see, there are IMS team, which is a dedicated team per customer. Then on-premises support also available through METS team, which is a shared team, because shared team means same engineer attend to multiple customers, right? On the remote team, you have remote support, you have 2 teams fundamentally. One is ITOC, which is proactive in nature. Proactive in the nature in the sense, before customer complains an issue, ITOC knows there is an issue, because there is an NMS, they have been monitoring 24/7, and they will do the fixing of those issues. Fundamentally, it is for S4N support. We also got a GDC, which is reactive in nature. Reactive in the sense is mainly for the end user computing support. There is a fault, customer calls the GDC, and GDC provides a solution. Either GDC try to resolve the issue telephonically. If telephonically not possible, they use FFA, field force automation or some kind of tools, and make sure a field engineer is reaching the customer to fix it. In case remotely not possible, somebody will go to the on-site to fix the problem, right? Some of the customers we are managing it from ITOC and GDC. It's given here, as you all know that we manage not only the from S4 and some of the customers or end user computing remotely management. We also provide some support for the OEMs like Lenovo, Acer, Dell, and all. We support those customers. Acer as a customer we handle. We support Acer's customers as well, right? You maybe some of you are already providing these services, right? Okay. iTalk is concerned what exactly service they provide. iTalk provides the continuous network monitoring and management while customers still have a control on their environment. We help the customers for fast adoption, and we help the customer to provide high performance and availability, and we help the customer to get their return on investment faster, right? So these are the three things a customer gets an advantage, right? From the HCL iTalk, we connect with all the technologies of customers like data center, end user computing, IoT, LAN, WAN, servers, applications. All the things we can manage it, monitor it from the central iTalk, right? 24/7. And combining Pondicherry and Noida, we got about 600 seats. Less than 50% is currently utilized. Still, we have expansion to grow with more engineers, more seats as we sign up more customers contracts, right? There are people who are L1 to L3 level, L1 level support into L3 level. There are ITL defined process, and there are NMS tools which are available for management. So we have the people, process, tools. So this slide talks about L1 to L3 support, preemptive responses, and we have got a service desk as well. Service desk is fundamentally based on the CA. CA is a little futuristic in the sense we place the order, probably it will take 3 months more to deploy. Currently, we are using a different set of CRM currently. It is also an ITIL based. So what is managed services means? Managed services means if you have to provide managed service or remote management services, etc. Remote management services, broad range of services that are used to monitor and maintain servers, network security, operating system, software application, and also solutions in order to operate at a desired level of availability and performance. The person who provides the service is MSP, that is basically managed service provider. The services are provided in proactive and predictive manner, right? And there are SLAs on every customer in terms of responses, resolution. There is an SLA signed up with the customers for these services. Okay. So you see how the iTalk is managing the customers. So you see the below the dotted line, there's an entire customer infrastructure that has all the customer network elements, servers, applications, data center, everything. So we have a collector, which all the devices which communicate with the collector, which is you see a PC there. The PC connects to the iTalk, right? So iTalk has a different set of NMS, different set of people, L1 to L3 level, different people are there, who will be monitoring based on the alerts coming from the collector here. Whereas all these devices, regularly they are collected, the required information by the local collector, and then it is sent to iTalk. Like this, there will be number of customers. Each customers will have will have a collector and a set of elements actually. From you attending from the field, you will be maybe responsible for a certain set of customers for the entire local management, and whereas this is iTalk, which is here, they are common for multiple customers providing the higher level support. They try to fix some of the issues remotely, or they 100% of the issues, of course, it's not possible to fix it remotely. In case they are not able to fix it, they work with you to get it fixed for the customers, right? So high level architecture of the NMS architecture, which we are trying to put, is we have iTalk, above the dotted line is iTalk, below this is customer environment. Customer will have any kind of NMS. Sometimes customer will have Mastro, customer may have a HP OpenView, customer may have or maybe he is having the CA tools which we have provided. So these NMSs are integrated with iTalk. We have a manager of managers, and we have a CA service desk which will manage all the trouble tickets, etc. The customers, basically there are 2 times the supervisor has come, but actually one is the customers. The customer supervisors are the L1 to L3 managers. They access to the service desk to understand the trouble tickets, and they also access to the manager of managers screens to get detailed information. or they go to the customers networks in case there is an SLA to remotely fix also. There is an SLA with the customer, they get into secure connection with the customer network to fix remotely certain issues as well. Customer service desk trouble ticket can be created over phone or email, and the service desk also is integrated with SMS notification as well as a video, large video walls where people can see it here when there is a fault in the customers. So the integration is concerned. We have the ITOC with all the servers, firewall policies, everything inside. There are users, there are servers, there are security firewalls, etc. I just put it as a cloud, whereas the end users are concerned, the customers are concerned, multiple customers, they come through internet or lease line or kind of MPLS connections to the ITOC from the connectivity perspective. So that combines that about ITOC. Then I will talk to something about UAM and then a little bit about Mastro. Then we talk about some of the questions which are maybe coming up in the windows, right? CA-UAM, remember we will have a detailed deep dive session, maybe 3-hour session later sometime. Right now you can understand from the conceptually what is the CA is all about, what are the modules, etc. Right? CA is concerned, as I told that it will be a 2-stage or 3-stage NMS management from the network elements. There is a collector, and there is also a centrally there is another hub is there which is connecting to the customers. So in between connection, customers and the ITOC, there is a secure tunnel. SSL tunnel is there through which the customers network resources are managed. So every customer has a collector, and the collector connects to the ITOC using a secure tunnel, right, over internet or lease line or whatever it is, right? Then different components. One is on the left side, these two elements is part of the ITOC. It has some portal dashboards to see the customer, some of the statistics and performance and fault. And at customer side, it has a hub which establishes a secure IPsec tunnels or a secure SSL tunnels with the ITOC. The hub is fundamentally a software which is running on a virtual machine or a physical machine. And every server, customer may have different servers, maybe VMware or some Windows server on the top. It is running some MS Exchange or something like that. So every parameter needs to be monitored. Will have a probe installed. It's a small software piece which is installed in the server, and then there is a robot. A robot fundamentally collects all the information from all the probes, which is also a different software elements only from the robots, and robot will send it to the hub. Hub will relate to the ITOC. So this is the general architecture of the end-to-end perspective, how the elements will be managed. Earlier, so far, if you see the whatever we are doing in ITOC is management is based on the ICMP ping and also SNMP based. Now the CA is going to enable us to monitor and manage multiple things, multiple applications. As you can see, we can manage SAP, Oracle, MS Exchange, plenty of things we can manage because it has a probe which can be installed in the server to collect all the statistics and send it to ITOC for monitoring, right? So we can, our offering suddenly has become much larger from to offer to the customers. So that is about the CA, but of course CA you will have 2-3 hours of session later on, including demo, right? So right now let's talk about Mastro. Mastro is fundamentally a manager level tool which will be there in the customer places. So Mastro has, as you of course we as you know, we have nearly about 40 plus customers already using it. So there are 3-4 modules which are part of the Mastro. One is EAM. EAM is the infrastructure management. The EAM module has fault management, performance management, configuration management. There are a lot of reports and other things are possible with EAM. And the second one is ISM service management. Service management takes care of the ITIL process when the trouble ticket is raised till it is closed. What are the different actions we will do? What are the SLA? How we are protecting? So those type of things are taken care by the ISM module. And third one is EAM. EAM is basically for the asset management, IT assets management, like in every element in the customer place. It could be desktops with memory, disk, software versions, both hardware and software kind of inventory can be centrally managed using the EAM module. So in summary of the Mastro is one is EAM, and ISM, and there is also one more module, CIM. CIM is for mainly for the desktop management. I put a blank on the top. The reason is I think it is currently it is not pushed to the customer because they are reworking some of the offering under the CAM. But later sometime the CAM is available with the new set of features. Maybe you need to hold on for some time in case you need to talk to customers. We can do desktop management remotely or fix certain patches, push some patches, etc. Some of the activities which you do on the site, some of them, not 100% not possible to fix the issues. Only some of the issues we can remotely fix it. And also we can extend the customers from 9/6 support, that is 9 hours, 6 days of support, to 24/7 support from the ITAC perspective. So that means customer can reach out to us for any kind of issues. We will be able to help them. To the time you get more clarity. I'm just putting the agenda back to we discussed about FCAPs, different protocols and technologies which enables, and then we talked about how to prepare the network with all these configurations. We talked about what is ITOC does, and we talked about the components of ITOC, the architecture of ITOC, and we talked about Mastro, some components which are there. So that was the agenda we had planned for you today. So what we are going to do is going through the some of the questions which are coming up on the chat, right? So this is the last slide, and as you see, you'll have to become an expert on the NMS. Probably post this training, you need to learn a lot, right? So what you learned in a little bit of everything, there are multiple slides we have gone through. You will have to do deep dive learning, and if you like to learn, there are multiple ways of learning it. It is not always, there is a classroom training is required for you to learn. You just need to decide you wanted to learn, you will be able to learn, right? And it is not possible, obviously you are all adult, it is not possible to teach, but we can make you learn, right? So that's a agenda. For today, I'm going to go through the chat window now and to understand if there are any questions. I think we have exceeded the time by 17 minutes, so I hold you for 2-3 minutes more to see if there are any questions. Oh, I just now see there is a voice is breaking written. I can't help now. The session is over now, so I can't say voice is breaking. I can't help right now. Yes.